Thanks for joining us this evening for the Scope Users Evening. This year we're trying something new by visiting one site to highlight their accomplishments and to show off some of the latest developments from Scope that we believe will make an impact on your field monitored research and workflow. Today I'm joining you from the Athenula A. Martino Center for Biomedical Engineering at MGH in Boston. The NYOX platform brings many exciting updates to the field monitoring workflow and new capabilities not previously available on the first generation acquisition system. What I'd like to do this evening is take you through how MGH has adopted the NYOX in their field monitoring workflow, highlighting several of the advantages. I'll then take you through several acquisitions, using both the new Scope Effects and the new NYOX-sdk, which is a scripting interface for the NYOX which allows for autonomous operation and integration with scanner sequences. Let's go in and begin. We'll demonstrate NYOX-sdk's ability to autonomously operate NYOX hardware by performing two experiments, looking at how high-strength gradients, like the one on this SEMA, require careful planning when developing a sequence. To start this off, though, let's take a quick look at the experimental setup, including how the new NYOX platform is integrated into the SEMA bay here at MGH. In this installation, the first generation acquisition system takes up a significant amount of space in a small MR equipment room. This impedes movement around the equipment and can significantly reduce flexibility in designing equipment setups. Additionally, the first gen acquisition system required many connections into the scanner bay through the penetration panel. With NYOX, dedicated penetration panel pass-throughs have been eliminated and replaced by a single fiber optic connection which can pass through any pre-existing waveguide. Let's see the difference with the NYOX installation. We've removed the old acquisition system and its associated cabling and penetration panel connections. In its place, we install the NYOX controller. The NYOX controller is light enough that it can be installed anywhere in the bay. For this installation, we just place it on a nearby table. This opens up a significant amount of space in the equipment room. We will also hook up the NYOX controller while we're here. Inside the Faraday cage, we will make a few changes as well. Again, we will remove the pen panel cutouts needed for the first-gen acquisition system. We will place the NYOX base and attach the single fiber connector. Cabling to the camera has also been simplified. It now uses the Odoo MAC connector. Having seen how NYOX can change the setup of your system, let's take a look at a real installation at MGH.
Welcome to the Siemens SEMA X equipment room, and over here to my right, we have the all-new NYOX controller system. So this is all unpackaged and connected, and which we've been using for a few months over at the Martino Center now. And as you can see, we have the back of the controller here with all of its connections. So the Ethernet cable, and then followed by that, we have the reference clock as well as the trigger. So you can connect the trigger either through BNC as well as using a fiber optic cable. And then we have the data line that gets fed through to the scanner room. Kind of the workflow that we've been using this as is connecting actually through Wi-Fi using our laptop that houses Scope Effects. You could also connect via an Ethernet cable onto the network. And so our experience has been really great. We've been very happy to use the controller and the NYOX base to acquire our data on Scope Effects for 2D spiral and APIs. So whether they've been acquired through PulseSec or just through some of our Siemens sequences, we've been able to acquire scope data, the trajectories, and be able to reconstruct our data offline in that nature. And so it's been really easy to use. It's very portable, so we're able to kind of disconnect anything and power off and connect when we need to reuse the system. Okay, and now you're all joining us in our new 3 Tesla bay over at the Martino Center, where we have the NYOX base set up in the bay itself, which gets connected to the controller in the back equipment room where we were just at. And that connection is all made using this fiber optic data line that gets connected to this base here. And then what we also have is the power supply, which is spewed over here and gets connected. And then as you can see here, we have this interactive NYOX base system, which we're easily able to see that the head itself gets connected using this connector, as well as see that the controller itself gets connected. And now this is all then connected to our dynamic field camera, which is currently sitting on our scanner bed. And so once we have these connections enabled, as well as the controllers turned on, then we're fully operational and ready to go, and able to use the NYOX space for kind of the brains of the operation, so do the transmit and receive components that gets then sent off to the controller, and then that gets then fed off to the scope effect software that we utilize. So, okay, now that we've explained kind of the new hardware components, the controller, and the NYOX space, I'll pass it back off to Cameron, who's going to continue on with the demo.
Thanks, Paul, for setting up the system for me. I hope you're having a great ISMRM. I'm now in the control room live, joined by Yuting, who will be running the scanner for today's experiments. Let's look at how ScopeFX connects and interacts with the controller. In contrast to previous versions of ScopeFX, which ran directly on the acquisition system, ScopeFX is now a standalone application which can be installed on any Windows computer. ScopeFX allows users to manually prescribe and execute field monitoring experiments. In addition to having a redesigned user interface, it now directly saves the field monitoring session to the user's local hard drive, eliminating the need for data to be manually retrieved from the acquisition system after the scan, speeding up the user workflow. Also new to this version is a completely reworked and improved data format. All scans within a single scan session are now saved in a single H5 file, reducing the number of files you need to track, improving data management and safeguarding experimental results. Additionally, scan session protocols can be saved just like on the scanner, allowing for the same set of scans to be acquired repeatedly without having to manually input the same parameters at acquisition time, reducing the risk of incorrectly acquired data. All right, so at this point we're set up physically and we're ready to start the scans. The first scan I always like to do when we're working with the NYOX is a sanity check. So we're going to come up here and just click New Scan and call it Sanity Check. And all this is a single FID that is internally triggered, and we're using that just to make sure all of the probes are alive. So we're going to set that up and go ahead and click Start Scan, and you can see the queue is running already, and we're getting the data in, and this data looks beautiful. You have this single exponential curve showing all the probes are functioning. The next scan we're going to do is the camera locator. And we're going to do this by going up to Camera, Locate Camera. And all we have to do on the ScopeFX side is hit Start Scan, which I've done. And Paul, whenever you're ready, go ahead and hit Start on the scanner.
Right.
And you can see the data coming in now. And we have a new field model set up. We can take a quick look at this field model just by going up to Scan, View Field Model. And just like in previous generations of ScopeFX, we're able to see this 3D output of the probe locations, including the average, so we can see if we're centered well. From here, we're going to set up a new scan. And this first scan, we're going to do completely manually. So this is an EPI scan that we're going to do just so you can see the manual workflow, and we'll give it a name, EPI version 1. There are 4 dynamics and 55 milliseconds. Trigger ignore, we're going to set to 100. Make sure the internal trigger's on, and pre-scan 5 or 10? 10. Okay, so we're set. I'll go ahead and hit Start, and whenever you're ready.
Go.
And we're just going to watch it come in on the scanner, on the ScopeFX screen. So here we're seeing the syncs and the pre-scans come in, and now we're getting the trajectories themselves coming in. All right, so at this point we've seen how to acquire data using the NYOX system and how to look at some of that data in the ScopeFX. What I'd like to do now is introduce the NYOX-sdk. The NYOX-sdk we're very happy to have released as part of the NYOX system, and what it is a programmatic interface for being able to operate the NYOX system without using ScopeFX. This is going to be very powerful for you if you're interested in being able to share your acquisition parameters with the larger community, say as part of reproducibility. You can now share this script that will run the NYOX system for a specific sequence. This is also going to be very powerful if you need to be able to reliably repeat an acquisition, say something like a daily QA protocol. The NYOX-sdk also has the built-in ability to start processing that information as well. So you can not only run the NYOX platform, but you can also start processing. What we're going to do today is just a very simple demonstration using 4 EPI sequences. We're going to take an EPI sequence that is unipolar with readout, measure that, take another sequence which is EPI unipolar without readout, and we're going to be able to compare the two with and without readout, essentially being able to see the eddy currents that are strictly caused by a diffusion. Then we'll also repeat that with bipolar gradients instead of the unipolar gradients. And from there, we'll be able to see just the impact of the bipolar gradients. All of these sequences and the acquisition script will be available after ISMRM. So let's go ahead and start doing this. So to execute this, it's like any other Python script where you just enter Python and the script name. Also, do watch the scope effects screen as well, because as this is running, you'll see the data coming in on scope effects. So I'll go ahead and hit execute, and then Paul, if you would hit start. So you can see the data already coming in, and you can see the acquisition's complete for both of them, and we have data that has come up. This is, let me bring this over visible into the window. What you're seeing is, on this first row was the normal PGSE, the one with the readout train, going across the B0 and the 3 directions we acquired. So these are just the, we're looking at the K0 term here. And you can see with the readout train, there's some interaction with the K0. However, without the readout train, what you're seeing are the eddy currents that are strictly from the diffusion lobe. And this bottom row, what you're seeing is the addition of the term from the diffusion along with the B equals 0 from the last one. And you can see very, very similar structure, which gives us some indication that the diffusion eddy currents and the eddy currents from the readout train themselves are able to be put in superposition. You can just add them together. I'm going to close this, and then it's going to automatically start recording data from the bipolar sequence. And it will produce the same output from that. So now it's acquiring. Paul, if you go ahead. Okay. This is me while I'm in editing mode. Just wanted to go through some of this data a little bit more in depth, since we're having a lot of abstracts this year on modeling the eddy currents of diffusion and using those models in image reconstruction. So looking at this graph that just came up, what you're looking at are the eddy current measurements only. So we turned off the readout gradients, as I think I said earlier in the video, of the monopolar, which are the blue lines, and the bipolar sequence, which are the orange lines. Now, the first thing we can see is the eddy currents are much smaller in overall magnitude for the bipolar. This is largely expected. And both the X and the Z direction, they're in opposite directions, probably because the diffusion lobe at that point is of opposite magnitude. However, what caught my eye and tested this a few times to replicate it was the changes in the eddy currents in the B0. This really wasn't expected, and is one of those things that ends up making you ask questions about the model that you're putting together. A simple change in the way the diffusion encoding is programmed changed the entire eddy current structure of the sequence. Now, without actually having measured this, it's not necessarily obvious that you should have to change the model of your B0. This basically underscores the need to always be able to check your sequence very thoroughly with something like field monitoring to really understand what data you're putting into or image reconstruction. This could also lead to ideas of how do these eddy current structures change day to day, or with field service engineer visits. And at this point, I'll send it back to VideoCam. And this last piece of the demonstration is essentially a teaser for the next demo. And in that demo, you'll be able to see the scanner actually run the scope system, the NYOX system, using the NYOX-sdk built into the scanner sequence. So much like how we did today, using a Python script to run the NYOX system, you can also use the sequence itself to run the NYOX in order to capture field monitoring data without having to actually interact with the NYOX. This is going to be excellent for workflow for large-scale neuroscience, where you need to be able to get the subject in and out without having to deal with multiple other steps. So what you're seeing right now is they're collecting data on a GRE. It looks like a dual echo GRE, monopolar, and you're actually able to see the data come in real time on the scope effects. You do see them monitoring the scope effects, making changes. Those are purely visualization. It's not actually setting up the scan itself. All of that is done by the scanner. And there you can also see the gradients in real time. The next sequence they'll set up is a EPI sequence. This is a diffusion-based EPI that automatically controls the NYOX system using the NYOX-sdk. And here you can see the raw data, and Rudy's going to change the output of the scope effects, which again, this is just purely cosmetic. It's not changing any of the prescription. He's going to change it so that you can see the trajectories. So he's chosen the X, Y, and the Z trajectories for display. And that about wraps it up. Thanks for this demonstration of the NYOX and the NYOX-sdk. Sorry I can't be with you live. Sounds like something has probably gone wrong if you're listening to this part. If you have any questions, reach out to me at cameron.cushing@scope.ch, and I'll get back to you. Thanks a lot. Bye.